Section 4.4 is on simplifying algebraic expressions involving radicals. So when you see the word algebraic expressions, that usually means there's some variables involved. So we're just going to do a little investigation first, and we're going to evaluate each of these variable expressions that involve radicals for each of these values here, listed along the column here. So x equals -2. We try to find the square root of -2. That's not defined. It's not a real number because the square root of a negative is undefined. If you try to find the square root, put a value of x of -2 in the second expression, you get -2 minus 1, which again is undefined or not real. But the last one, if you try to put in a value of -2 there, you get 3 minus a -2, which is the square root of 3 plus 2, which is the square root of 5. So when you plug -2 into the last one, it does work. The next one, if you plug in the square root, put x as a value of -1 inside the first expression, you still get not real solution. And then you plug it into the second one, you get -1 minus 1, which again is still a negative value, -2. So that's not real, or undefined, whatever way you want to write it. And then if you plug it into the last one, you get 3 minus a -1, which becomes the square root of 3 plus 1, which becomes the square root of 4, which we can further simplify as 2. So that does have value as well. When we take the next one, x equals 0, and plug it into the first expression, we get the square root of 0, which is 0. If we plug it into the second expression for x, we get 0 take away 1, which is the square root of -1, which is again not a real number, or it's undefined in the set of real numbers. And we do it into the last one, we get the square root of 3 take away 0, which is the square root of 3, which is a value that's in the set of real numbers. The next one, the square root of 1, is 1, so that works and is defined. The next one, we plug it in for x in the next expression, you get 1 minus 1, which is the square root of 0, which is 0, so that has defined value. And if you plug it into the last one, 3 minus 0, oops, 1, sorry, not 0, 3 minus 1, you get the square root of 2, which is also defined. And the next one, if you plug in 3 for x, that is a value that is defined. It's irrational number root 3. And if you plug it into the next one, you get 3 minus 1, which is the square root of 2, which again is a defined value. And if you plug it into the last one, 3 minus 3, you get the square root of 0, which is 0. And if we evaluated x equals 4, the next one, we get the square root of 4, which is defined as 2. The next one, if you plug it in for x, you get 4 minus 1, the square root of that, which is the square root of 3, which is a defined value. And if you plug it into the last one, 3 minus 4, now you find that this one is -1, which is now not real or undefined. So when you look at all the results here, you can see that basically values which, when you plug into the expression under radical sign, make it have a negative value are going to be undefined or give you a non-real solution. So when you're simplifying expressions that involve radicals, and these expressions have variables in them, you have to state some restrictions as to what x can be so that you want the expression to be defined. And so that's what we're going to be doing in this section. So the restrictions, by definition, are the values of the variable in an expression that ensure that the expression is defined. The square root of a negative number cannot be evaluated. This means that the expression under the root sign, the square root sign, must be greater than or equal to 0. Because you can find the square root of 0, you can find the square root of a positive number, but you can't find the square root of a negative. So therefore, when it's a square root sign that's involved, you must look at whatever's under the expression under the root sign and set it greater than or equal to 0 to find out where the restrictions are. Now, in addition, you do have to consider if that square root sign is in a denominator, then you can't have it equal to 0. Okay? So to find the restrictions for a radical of the form square root of an expression, we need to solve the expression greater than or equal to 0. So note, if the square root of the expression is in a denominator, then solve the expression just greater than 0, because you can't have the denominator equal to 0. All right, so let's take a look at these expressions here. So for the first one, you have the square root of x plus 3. So for your restrictions, you would need x plus 3 to be greater than or equal to 0. So if you solve that, you just basically solve it like you would a linear equation. Much the same rules for inequalities. The only thing you got to be careful of when you have inequalities is if you divide both sides by negative, you have to switch the direction of the inequality sign. And that's because, for example, if I have 1 is less than 3, that's true. But if I divide both sides by negative, -1, -3, then the sign is not true anymore, that -1 is less than -3, it's the other way around. That -1 is actually greater than -3. So when you divide both sides by -1, or any negative for that matter, your direction of your inequality switch because of the nature of how positive and negative numbers work. All right, so just going back to where we were, if you have x plus 3 is greater than or equal to 0, this is just like I said, solve it as you would a linear. You'd basically subtract 3 from both sides. So this would become x is greater than or equal to 0, take away 3, or x is greater than or equal to -3. So if you pick x's that are bigger than or equal to -3, this expression here should be defined. And you can just check, if you plug in -3 for x, -3 plus 3 does give you 0, and you can find the square root of 0. If you pick something bigger than -3, like -2, -2 plus 3 is going to give you 1, and square root of 1 is defined. But if you pick something that's not bigger than or equal to -3, for example, -4, -4, go back into your expression, -4 plus 3 is -1, and the square root of -1 is not defined. All right, so the next one you would need for your restrictions, x minus 6 to be greater than or equal to 0, which means x has to be greater than or equal to 6, because if you add 6 to this side and add 6 to that side, right? The next one, you need 4x plus 2 to be greater than or equal to 0. So again, solve this as you would almost a linear equation. So you want to subtract 2 from both sides. If you subtract it from this side, you're just left with the 4x. And if you subtract it from the other side, you've got 4x is greater than or equal to -2. And then you divide both sides by 4. And that shouldn't be an issue because you're dividing by a positive, so you don't need to switch the inequality sign. You can leave it as a greater than or equal to -1/2. So you would need to pick x's that are bigger than or equal to -1/2 in order for this expression to be defined when you take the square root of it. The next one you would need 6x minus 2 to be bigger than or equal to 0, which means 6x would have to be bigger than or equal to 2 if you add 2 to both sides to get the 6x by itself. And then you have to divide both sides by 6. So x is bigger than or equal to 1/3. The next example, you need 2 minus x to be bigger than or equal to 0. Just going to move that up a little bit. So this is one where you have to be careful now because, okay, bringing the 2 over would mean subtracting 2 from both sides of the equation. So you'd be left with -x greater than or equal to 0 minus 2. And then negative x would be greater than or equal to negative 2. But here, we're dividing both sides of an inequality by a negative 1 to get x by itself. So that means, and I'm going to put that in red, that that's going to switch now to less than or equal to, because you've divided by negative. And then your answer would be x is less than or equal to 2. And you can check to see if you did it right, because if you pick a value that's less than 2, for example, less than or equal to, so 2, say if you pick 2, 2 minus 2, you plug it back into the expression, would be the square root of 0, which is defined. And if you put something like 1, which is less than 2, 2 minus 1 is 1, and the square root of 1 is defined. So you know you've picked it right, whereas if you forgot to change the sign and left it as greater than or equal to 2, you would end up with something like 2 minus 3, which is a negative, which doesn't make sense. It's not a real number. All right, so the next one, you need 12 minus 3x greater than or equal to 0. So then if you want to get the x by itself, you'd subtract 12 from both sides, so 0 take away 12 on this side, because it was positive over on the other side. So then negative 3x is greater than or equal to negative 12. And then you want to divide both sides by negative 3. And again, you're dividing by negative, so your inequality sign is going to switch to a less than or equal to. And then that would give you x less than or equal to 4. Would make x's that are less than or equal to 4, when you plug them into this expression, would make the square root of a positive number or 0, and you will be able to find its value. All right, so the next few examples just talk about what I mentioned on the previous page about if you have the radical expression in a denominator. You got to also consider the fact that you can't have the 0 in a denominator. So that means when you're looking at the restrictions, you just have to consider making sure that the expression under the root sign is only greater than 0, not greater than or equal to 0, because you can't have it equal to 0 if it's in a denominator. So that would mean in the first one here, that you would need x plus 7 to be greater than 0. Okay? It cannot be equal to 0 because that would give you 0 in the denominator. So you would want to solve for x. You subtract 7 from both sides. If you subtract 7 from this side, it's gone. So you're just left with x is greater than negative 7 would be your restrictions. And the next one, you would need 3x minus 4. Again, only greater than 0, not equal to 0. So if you want to get rid of that negative 4, you have to add 4 to both sides of the equation. So if you add 4 on this side, it's gone. And if you need to add 4 on the other side to balance your equation, or inequation. So 3x is bigger than 4, and then you have to get x by itself. You need to divide both sides by 3, which is a positive, so you don't need to change the direction of the inequality sign. And you'll end up with 4 over 3. X is greater than 4 over 3 would make that expression defined in the set of real numbers. Okay, so up to this point we've looked at linear expressions under the radical sign. What happens if you've got powers of x under the radical sign? So when you think about x squared, no matter if x squared is going to be defined all the time, because when x is positive and you square it, it'll always be a positive. And when x is negative and you square it, it's going to be a positive value as well. So x squared is always a positive value. Since positive squareds are positive and negatives squared will always be positive. So therefore that should be defined. It shouldn't matter what x is. Therefore x can be any real number when you're talking about raising an x to an even power. That would basically be the same idea, because positive numbers raised to an even power will always be positive, and negative numbers raised to an even power will always be positive. So again, this will If we just move down ahead here to x to the 4, x to the 4 is always positive. Therefore, x is real. Any real number would be your values for which this expression, the square root of x to the 4, would be defined. Now, when we get something like the square root of x cubed, though, it's a little bit different, because a positive number cubed is positive, but negative numbers cubed is a negative. So therefore, if you're looking to find the square root of a value that's being cubed, you would only be able to evaluate it if the x is a positive number. Because if x was negative, when you cube it, the result is going to be negative, and therefore you cannot find the square root of a negative number. So therefore, in this case, it's only defined if x is greater than or equal to 0, because 0 cubed is 0, and you can find the cube root of 0. And similarly, x to the 5 would only be defined when x is greater than or equal to 0, because negatives raised to the power of 5, a negative value to the power of 5 is a negative. And then you can't find the square root of it. So if we kind of summarize those restrictions there, when it's an even exponent, x should be all real numbers. But when it's an odd exponent, x to an odd exponent, and you're talking about this type of a form here, x to an odd exponent, you would only have be able to define that expression if x is bigger than or equal to 0, provided now it's not in a denominator. If the square root of x to the n in denominator, that didn't look like an m. Oh my. Try again. X in is in a denominator. Even exponent would be x is real except x not equal to 0, and odd exponent would be x just greater than 0. All right, so if we're simplifying radicals with an index of 2 containing a variable radicand, then why is it not correct to say the square root of x squared is equal to x? So if you look at some examples, for example, if you have 2 squared and you take the square root of that, that's equal to the square root of 4, which is 2. So in that case, it is true, because if x was 2, the answer is the square root of x squared is x. But if you consider a negative value squared, and you take the square root of it, negative 3 squared is 9, so you can find the square root of it, but it is not the value of x, which in this case x is negative 3. It's the opposite of x. This is equal to the negative of negative 3. So when we're saying the square root of x squared equals x, that's only true if x is a positive number. Because if x is a positive number, they're both the same. The answer and what's being squared is the same. But if x is a negative number, it ends up being the opposite of it. So the value of the square root of x squared must be positive, since the square root refers to the principal square root, which is always a positive. So this means that when we say the square root of x squared, we want it to be equal to the absolute value of x, so that we ensure that it's positive. And the absolute value, by definition, is the distance that a number is from 0 on the number line. So when we have the absolute value of -5, for example, that means -5 is 5 units away from 0 on the number line, so the absolute value of -5 is 5. And the technical definition of the absolute value of x is this one right here, which says that the absolute value of x is x if x is a positive number, and it's the opposite of x if x is a negative number. So that gets a little bit confusing. So when you're talking about the square root of x squared, rather than writing the absolute value of x all the time as our answer, because that's technically what we're saying, that the square root of x squared, because we're looking for the principal square root to ensure that we get a positive answer, we want to take the absolute value of whatever x is. So just to make it easier when we're doing this section, we are going to assume that x is the principal square root of x squared, and rather than writing the square root of x squared as absolute value of x all the time, we're just going to say the square root of x squared is x. So we're basically going to assume that all the x's we're talking about are positive x's. Okay, so if you're asking to simplify some powers of x, when we see the square root of x squared, we can assume that it is a positive number squared, and that the square root of x squared is x. If we see the square root of x to the 4, that means what expression multiplied by itself gives you x to the 4, which would be x squared, since x squared times x squared is x to the 4. And x to the 6 would be x cubed, since x cubed times x cubed is x to the 3 plus 3, or 6. Now, if you remember your grade 10 exponent rules, the square root is the same thing as raising to the power of a half. You can basically realize that the square root of x squared is the same as x to the 6 to the half, which is the same as x to the 6 over 2, which is x to the 3. So basically, if we have an even power and we're square rooting it, it's always going to be half of whatever that power is. All right, next examples here now are basically simplifying these expressions involving powers of x under the root sign. So when you see an odd power, that's not a perfect square. So we kind of approach that the same way we approach it when it's numbers. We take out the largest perfect square factor, which would be an even power of x, and then what's left over would be the rest of it. So in this case here we have x squared, and then be one more x to make x cubed. And then the square root of x squared can be separated, just like we did with numbers, and the square root of x squared we're going to simplify to just x. So this would be x root x. And similarly, if you have x to the power of 17, again, 17 is not an even power, so you don't just take half of 17, but you break it up into an even power times x to the 1. And then you can separate the square root of x to the 16 times the square root of x to the 1, or just x. And the square root of x to the 16, we basically like taking half of 16, or x to the 8. And then you'd still have the square root x left. Now when you combine them with numbers and radicals, you basically do the same thing, but you do the numbers and the radical part, variable part, I meant to say, variable part separately. So root 8 would be 4 times 2, and then the x cubed would be x squared times x. You separate that into its perfect square part. So then the square root of 4 can come out as a 2, the square root of x squared can come out as an x, and all you have left inside is the remaining 2 and the x. And the next one, we have 4 outside, and 18 has a perfect square factor of 9 times 2. And x to the 5 would break up as x to the 4, the even part, and the leftover x. And then we'd have 4 times the square root of 9 would come out as a 3, and the square root of x to the 4 would come out as an x to the 2. And then we would be left with this 2, and this x are the only things that would be left under the radical sign. And the next one, we have negative 7 y squared, and 8 can be broken down as 4 times 2. And y, we can separate as y to the 4 times y. And that would be negative 7 y squared. And then the square root of 4 would come out as a 2. The square root of y to the 4 would come out as y squared, half the exponent, right? And we'd be left with the 2 and the y underneath the radical sign. And then we can simplify what's out front by multiplying those, and you get negative 14. And y squared times y squared is y to the 2 plus 2, or 4. And then we still have the root 2y left. Okay, so those are some examples, and these are the questions you can try in your book on pages 211 to 213 to help practice that.